Hello again, welcome back to Mr. Algebra. In this video we're going to show how to write quadratics in vertex form, and you can see right here vertex form is looking like this, and we're going to do that by completing the square, which is a means or method for also solving quadratics. First of all, standard form looks like this, so what we're going to do is we're going to convert this standard form into vertex form by completing the square. When you're in vertex form like this, you have the a on the outside. A is still the leading coefficient, so it's the same a you see out here. And the coordinate here is the h value, or the x coordinate of the vertex, and the k value, the plus out here, is no longer the y-intercept like it is over here. This is actually the y coordinate of the vertex. So this is why they call it vertex form, because the vertex is here and here. And most students will see that this is a minus h and wonder why is that h? Well, it's always a minus here, so one way of thinking of it is this is the opposite of what you see going there. So we're going to have two examples, one where we have a leading coefficient that is actually a 1 and one that has a leading coefficient that's not a 1. So we're going to focus on this one first. Okay, so the first step is to take this constant value and move it to the other side. So we're going to add 10 to both sides. Y plus 10 equals x squared plus 6x. So all I did was move the 10 over. Now the next step is where we actually complete the square. What we're making is a perfect square trinomial. We take this middle term right here, we take half of it, and that's going to give us 3, and then we're going to square it. So 6 divided by 2 is 3, 3 squared is 9, and we're going to add that 9 to both sides of our problem. So y plus 10 plus 9. Okay, so this side right here then becomes y plus 19. Now this right here is a perfect square, which means it can be factored back out into the same two factors twice. So the square root of this one is x, and the square root of that is 3 and 3. And we want to keep this sign right there, so plus and plus. So what we're going to do is we're going to rewrite this as x plus 3 squared. So we factor this out and then put it back into its squared form. Now the last step is to simply take this 19 and move it back over here. So we're going to subtract 19 from both sides, and we have y equals x plus 3 squared minus 19. Now my leading coefficient is 1, which tells me I have a minimum value. So this is a min function because it's the same one that was up here at the top. But my vertex is located at, now it's the opposite of this number here for x, which is negative 3, and then that number for y, negative 19. So now we know that this is a minimum. We can look over here and see, oh yeah, the minimum is actually negative 19.
For example 2, we have a leading coefficient that is not a 1. We have a 3 here. But step 1 is still to get rid of this 5, so I'm going to subtract 5 from both sides, and that will give me a y minus 5 is equal to 3x squared minus 12x. Now if you remember back to the completing the square videos, completing the square only works when your leading coefficient is a 1. So the way we're going to fix that is we're going to factor a 3 out of both of these so that what's left over in front of this x squared ends up being a 1. So when I factor a 3 out, I'm going to bring my y minus 5 down. When I factor a 3 out of this, I'm left with a 1x squared. And when I factor a 3 out of this, I'm left with a minus 4x. Now I do have to complete the square, and I'm going to complete the square inside my parentheses. So I'm going to rewrite this, leave some space. And remember, whatever I add to this side, I got to add the equivalency on the left. So I'm going to leave some space over here as well. So y minus 5. I'm going to put a plus sign here and put an underscore because I'm going to add something there, and it's going to be equivalent to what I add on this side. So 3 parentheses 1x squared minus 4x plus some unknown number. And if you remember, we take this middle term, which is negative 4. We're going to take half of it, and that ends up giving us a negative 2. And then don't forget that we're going to also square this. So this ends up being a positive 4. And you'll never end up with a negative here because you're always going to square this, and a number times itself will always come out to a positive. Now we added 4 here, so don't go rushing in and adding 4 over here, because even though we added 4, we added it inside the parentheses. There's a times 3, so if I were to distribute this 3 back out, yeah, I'd get the 3 and the 12 here, but this would also be a 12. So I actually had the equivalent of adding 12 to both sides. So I have to add a 12 here. So I'm going to simplify those. So y and then negative 5 plus a 12 is going to leave me with a positive 7. And then, of course, this right here is a perfect square trinomial, which means I can factor it into a binomial squared. And I'm going to take the square root of the first one, which is x, and the square root of the last one, which is 2. And I'm going to keep the sign that's in the middle, because the only way to get a perfect square to have a minus here is to have a minus here. Now the last step is to bring the 7 back over, so I'm going to eliminate the 7 from the left, and I'm going to eliminate 7 or subtract another 7 from the right. So this becomes a 0, and I'm left with y equals 3 times x minus 2 squared minus 7. Now remember, this is my a value. This is my leading coefficient, so that's the same one there. So that also tells me that my curve is actually going like this, which means I actually have a minimum value here. So when I figure out what the vertex is, so the vertex will be, remember it's hk, so it's this value for x and this value for y. So the opposite of that would actually be a 2, and I keep this one at face value, which is negative 7. So my vertex is located 2, negative 7, so it's actually in quadrant 4, but since my curve is actually going this way and I have a minimum, my minimum value happens to be negative 7. Remember, the min value or the max value is always the output at the vertex, or also known as the y value of the vertex.